To this video on dummy variable trap with example. I will try to show it first with R and then with Excel. So what is dummy variable trap? Basically what qualitative variables. When you have data on nominal scale, that is you can just name the things, that's called nominal scale. When you can order the things, that's called ordinal thing. When the differences are meaningful, it's called interval scale. When differences and ratios are meaningful, it's called ratio scale. So it has no numerical values, nominal variable, nominal scale variable, 0 if attribute is absent, 1 if it is present, or vice versa. It does not make any difference. I will explain. For example, if we have data on teacher's evaluation and male, female, so female is 1, male is 0. So dummy variables are basically indicator variables, categorical variables, qualitative variables. These are different names. For example, gender, race, color, religion, nationality, geographical region, party affiliation, political upheavals. Dummy variable trap, when you basically intercept coefficient x, intercept is a coefficient of x naught, which is a column of 1, 1, 1, 1, 1, 1. And when you introduce number of dummies equal to number of categories, their sum becomes equal to sum of equal to the x naught. It becomes equal to 1, 1, 1. So basically these are perfectly correlated. That's why we call it's a dummy variable trap. So we must have one dummy less than total number of categories, or we should exclude intercept. That will I'll demonstrate. So 0, the category which is called 0 is called a reference category, benchmark category, or comparison category. For example, if male is 0, it means if female coefficient is there, it means male is a reference category. Similarly, if north is omitted and south, east, west, it means the reference category is north. I'll demonstrate it in a short while. So all comparisons are made in relation to the reference category. If you have more categories, so then it's slightly difficult to interpret. What are the points which we should keep in mind? First, that number of dummies should be less than 1 than total number of categories. For example, if you have 4 regions, introduce 3 dummies. If you have 4 quarters, introduce 3 quarters. Or exclude intercept and include 4 dummies for quarterly data. Must always be interpreted, a coefficient of a dummy variable must be interpreted in relation to the reference category. So there can be interaction of variables. I have a video, you can see interaction of variables on that. Interpretation of dummy variables I mentioned already. I'll try to demonstrate it with the help of an example. Now this is a very commonly used data, which is basically teachers evaluation, basically course evaluation, whether it's a function of beauty. I have just displayed first 5 values, and I will introduce only gender here. Other variables you can include for your regression analysis, for econometric analysis. So I have computed another variable male, which is 1 minus female, advanced course. If course is advanced, course is intro, that will also play a role in course evaluation. So I have basically now introduced female, and I have also introduced female, and I have taken first 20 values. Set.seed means you will get the same values as I have. So this is now your data. You see, you have male here, you have female here. If you sum these 2 columns, it will be a column of 1, 1, 1, 1, 1, which is basically your constant, that is variable whose coefficient is intercept. So let's go to in practice. Okay, I have basically regressed 3 lines. 1, I have regressed course evaluation on beauty plus female. I have introduced only 1 dummy and intercept. Data is yours. I have basically selected a short data. Second variable is beauty plus female plus male plus intercept, and same data. Course evaluation on beauty, female, male, plus 0 means no intercept. So what do we get from these three columns? When I list these results, these are all arbitrary because it's not a full sample data. So here we say that female coefficient is 0.046 more than male, that is the course evaluation of being a female is 0.046 better than male, and male intercept, basically beauty coefficient is this one. Male intercept is 4.14, female intercept will be 4.14 plus 0.046. So male is your reference category. We say that female course evaluation is 0.046 better than male. No, in second case we have included both male and female. Again, it has software has omitted that category. In third model, I have excluded intercept. So intercept is not here. Now look at coefficient 4.186. It means that female is 4.186 better than has intercept 4.186 and male has 4.14. Again, the difference between these two, this 4.14 is the same as here. So again, the difference between 4.186 and 4.14 is 0.046. So interpretation remains same, that male intercept is 4.14 and female intercept is 4.18. Same is the case here when male is 0. So male intercept is 4.14. For female intercept is 4.14 plus 0.046. So I hope you got the point. I try to demonstrate briefly in Excel as well. So if you look here, I have created a column of 1, 1, 1, and basically if you not include intercept and include this column of 1, 1, 1, you will get same results as if you include it does not include this one and say intercept is needed. So you see, if I add here this plus male plus female, this will be a column of 1, 1, 1, and it will be exactly equal to your x naught. That's why we call it perfect multicollinearity, or we say that is dummy variable trap. This column K and column G are exactly equal to each other. So if I you see, if I take results here and if I include constant equal to 0 and I include this one, you will get similar results. I hope you got the point, and thank you for watching. Take care.